All right. Chris Gammell is an electrical engineer, podcaster, and design consultant from Durham, North Carolina. He has over 20 years of electronics design experience and now works on building IoT demos at Golioth. His talk today reviews techniques, tools, and resources for building the smallest dev shop out there. Please welcome to the Hackaday Supercon stage my friend, Chris Gammell.
Hi everybody, it's good to be back. As you may immediately hear, my voice completely gave out on me yesterday, but I didn't talk from 6 p.m. onward to try and get here, so hopefully it holds up. I appreciate all being here. Like Adam said, I do the AMP Hour, and I love this community. It's been a big part of my life, so appreciate you all coming. This is the first time I've done a presentation in a while, of course, but also the first time I've done a new presentation in a while. I found out you can actually do a presentation more than once. Did you guys know this? I didn't. Yeah, it's like, but every time I come to Supercon, I'm like, well, I want to talk about new things. So, anyways, a little grace for the voice and the new presentation. Hopefully, we'll get going here. So first off, let's start by defining dev shop. Dev shop, or development shop, as it is short for. Basically, you build stuff for people, and that might be building a full product. It might be just doing some services there, but some of them are really big. One of the ones back in Chicago, one of the guys I know there, 200-person dev shop. They've got like 10 projects going on, multiple streams of work. They just bounce between everything, and it's a tough business because you're basically trying to get streams of work going and keeping people fully busy all the time, right? That's how you survive as a dev shop. Some of the full service shops, and the way that you survive better is to offer everything. And so some of the full service shops do all this stuff, and all the way down to brand design and industrial design. Some of the ones that I used to work with, I was a subcontractor, and I worked with some that were like, yeah, we're doing like, brand design for like a weed company, while we're also doing like electronics design for this Fortune 100 brand. So it's just all over the map there. But as in any business, you also have support services. So we're going to go through some of this stuff, and really we're going to use this as our framework for how we're talking about these things, because what we really want to do is talk about the smallest atomic unit, which would be a dev shop of one. And I would consider my past life as that. Basically, we're going to use this OEDS, which is a terrible acronym, but one engineer dev shop here. So let's talk about why you'd want to do that in the first place. And the reason as a one engineer dev shop is the same reason that the big shops want to do that. You want to be able to bill more hours, right? So you might want to do that sort of thing. Not saying we're a super profit motivated community here, but if you went out on your own, you might be interested in making a living like this. One I think that is going to resonate well with this community is building more skills, right? So as you take on more of the work, you also get to do more of the stuff, and that's just great. That's what I want to do. I want to keep building more skills for the rest of my life. I want to be, someday I want to grow up and be Ben Krasnow. I'm never going to get there, but hopefully I will. Yeah, someday Ben. Yeah, I'm coming after your title. As a one engineer dev shop, you also have less communication overhead, right? So there's fewer interfacing, even internally. Even if I was a 5-person dev shop, right? Even internally, there is more communication overhead there, and so I might talk to myself, but that's pretty fast process. Another reason you might want to do this is because of the kind of the target market, and this is really the framework we're going to be talking about here, because we're going to mostly be talking about a proof of concept. The idea of taking a completely, a 1 million device deployment all the way to the production, from like a napkin sketch all the way to production. That would be insane as a one engineer dev shop. And so we're not really talking about that. We're going to be talking about kind of proof of concept. And the perfect is the end of the good. If you're trying to get something out in the world, if you're trying to prove out an idea, I think the one engineer dev shop really does that. And that's the type of work that I really like doing as a one engineer dev shop, is that building up just concepts and seeing, can this work? And you really need to see the entire product in order to see if it's going to work. Another thing I think will resonate with this group is just that it is very empowering to build these things, right? So the reason Hackaday IO projects exist, because they need it. People want to be able to see these things out in the world, and that's enough of a reason to build a thing. So hopefully, like I said, why does Hackaday care? Building projects. You might be building for the prize next year. You might want to just have more resources to build your own products and projects. And then if you ever want to go out on your own, right? Some of you might be at companies now. You might want to go out as into a consulting style role or dev shop type role, and I'll have a link at the end for that sort of thing. But let's talk about some caveats. First one, the lone engineer. Oh, wow, that's really big. Oh, that's on my screen. The lone wolf engineer. It's a myth, right? Even when I am a one engineer dev shop, so I just blew up my whole talk right here, right? It's not ever just one person. If I go and use a service or a product or like a service that we're going to be talking about here, that's run by 100 people somewhere else. It's outside of my shop, but it's not like I'm just doing everything and talking to robots. I'm talking to people. I'm working with people. Same with like CMs. Same with any kind of thing. Just because you're outsourcing doesn't mean that there aren't other people in the loop. It's more about who's in charge of that one thing. Another one is just because you can doesn't mean you should, right? So this is a communication thing with your clients. So if you are a dev shop, you are almost certainly working for a client. Maybe you're building your own product, but then you are your own client. But you should really be talking to them about what these trade-offs are. And we'll talk about some of the trade-offs here. Some of them are going to like this. Some of them are not going to like this. They might be like, yeah, you should go build this proof of concept. But I really care about my brand, so go and hire someone else for that sort of thing. So you really need to understand those kind of things there. There is going to be a significant thing of outsourcing. Outsourcing is a negative word normally, but outsourcing in this context is just using someone else's services or maybe even shipping some part of the work out as a subcontractor sort of thing. Again, kind of blows up the idea of a one engineer dev shop if you're talking to other engineers, using other engineers, but it's more about how can you do more of this and capture more of that work, understand how to control more of the final product as the engineer. And the final caveat is I am no longer a one engineer dev shop. I now work for Golioth, building demos, and a lot of that stuff is getting to work in that. I build mechanical, I do hardware design, firmware design, doing dashboards, that sort of thing. So I do operate in many of the roles we'll be talking about here, but I'm doing full-time work. So take all this with a grain of salt, as in any talk, I suppose. So let's talk about again. We're going to go through the different roles here. I'm going to start here because I know this role best. I think some of the things you'll see here in like kind of the electrical space, many of these roles would actually be multiple people. You might, if you're a 200-person dev shop, you might have an RF person. You might have 4 embedded people. You might have someone who's just a digital designer doing FPGAs, that sort of thing. Ooh, my voice is not doing great. Excuse me. Okay. So some of these things are, the EE design. We're also going to be talking about manufacturing, assembly, and testing, right? So on the design side, the way you can kind of start to do more of it yourself, right? So this is really just a trend in the industry. You see more integrated circuits. I thought that was kind of a fun thing there. But you see this in SIPs, system and package, SOMs, system on modules. RF combo things where you've got a microcontroller and some analog circuitry and a RF front end all in the same part, and it's just insane all these things that are happening. But as an individual designing these into your system, you can do so much more, right? You might just be writing the code, but then you're also flipping on the GPS unit. So this NRF 9160 in the top right corner, I use that part all the time. It's got a ton of stuff in there. It's crazy. And we'll talk about how you enable that on the firmware side. But other things you can do other than using these types of parts is using some of the design resources that are out there. So leaning on FAEs, that's something that I wish I would have done more as a younger engineer. As a small shop, you're not going to be able to do that as much. You don't have as much sway as I did maybe when I was at ABB and I had that name behind me. But they still play in that space. They still want to talk to you. They all want to talk up to the young startup sort of thing. So they also, a lot of them are providing tools. So look out for the tool builders that are out there and utilize those kind of things like Webbench. And then finally, I would be remiss if I didn't mention KiCad or KiCad. And so, just kind of the ability to access more of the design flow by using a lot of the tools and programs that are out there. You've always been able to do that, of course. You can always go and buy a license to a tool. But I think community and the open source and or free nature of it basically gives you access to more tools without having to dive into this thing and become a specialist. Because to pay off that $10,000 license, you need to get a bunch of work around that sort of thing. Now you just pick it up, you try it out, hopefully you get good at it. On the PCB side thing, again, everybody here understands this, but like the implication of having more access to PCBs and just the insane rise of PCB manufacturing capabilities into the low and fast market, it's unbelievable what you could do there. So like I say here, process improvements on the availability of 4 and 6 layers. A lot of the things we're talking about here is not necessarily just enablement. You've always been able to get 4-layer PCBs, not always, but you've been able to get 4-layer PCBs, but now they're so cheap and so fast that it's about speed improvements. So I can do more at the same time, but without increasing my cost as well. So, just starting with a 4-layer PCB, that's a huge deal as well. Process control as well. So I don't need to go and do a custom stack up. I can just use one of the vendor stack ups there. I just start from that point. I've done a talk here, I think, about RF stuff and getting started. I referenced Mike Osman's old talk from way back time, the first Supercon. And it's just gotten so easy to put RF stuff onto a PCB where you might not have felt comfortable doing that without having a really specialized stack up there. Hands-off process is another thing that we're going to see here, kind of a theme throughout, just not having to think about it. You send it out, it does its thing, and it shows up at your door, often very quickly. And DRC as well. It's kind of hard to send off. The board houses don't let you break your own boards often. I'm still really good at it. I still can send out a schematic, or I completely forget to hook something up. But on the DRC side, you're not going to be able to make something that's not manufacturable. On the assembly side, again, not going to be super surprising for this audience, but the availability of the things that you can do in your lab, if you want to in order to go faster, to do more yourself. Pick and place machines like the Lumen, these kind of low-cost infrared machines. I just on the amp hour this week, I just talked to the folks that do the Vapor Phase 1. So like prosumer level things that are coming into your lab as well, so that you can again do more yourself. There's often a startup time to learn these things, but once you have it and you have this kind of set of resources in your brain, in your lab, you can do a lot there. I think it's also important to realize just the kind of the set it and forget it kind of thing. So with the in-house assembly, you're going to have to do a lot of it. You have to maybe not babysit the machine, but you have to at least set it up and understand that sort of thing. But it's so easy to just chuck it over the wall to an assembly service and not think about it. And zero touch, no salespeople in the loop. That kind of thing is so useful to be able to iterate, because it's like an easy bake oven. You're just sending off the files, and it just shows up at your door. As long as your design's right, the service is going to make it easier to do that sort of thing. So the no-touch services, I think, are really, really useful there. And if you're in a real bind, if you really need to go fast, you go something domestic, and you get a board back in 2 days assembled. It's insane, the availability of that sort of thing. On the testing side, just the low-cost nature of a lot of the test equipment that's out there, and like what you can do in your lab. These, again, the access you might have had. So if you had to buy a $50,000 tester in the old days, you don't have to do that anymore. Having a $1,000 test machine like the Joule Scope here, it's just like, it's so easy to have that there and then take on more of that. Whereas you might have outsourced that to a test lab now, you're doing that in-house. You're providing that service to your end client. All right, this is going to go down as my most hydrated talk, I think. Okay, so again, we are focusing on things that allow the engineers to take on more of the process. And on the firmware engineering side, this is reference firmware ecosystem build tools. As many of you probably know, in the firmware space, we lean on the chip vendors a lot, and a lot of it is getting better. But even still, even the old stuff, you're starting from these reference designs. You're starting from example code, configurators. A lot of people might know STCube, but then also support as a single engineer dev shop, right? A lot of the chip vendors, they want to start broadening their support, so they've gone to kind of forum-based systems like DevZone, and we start to see that you can actually access the support, and that's something you should be doing. You should be, in order to take on more complex projects, you probably need to do more complex things. You probably need more complex support, but you can actually access that. Whereas 10 years ago, 20 years ago, you had to be that big company in order to do that sort of thing. Ecosystems, this is one of my favorites. So Mike and I gave a workshop where we were doing Zephyr on this Adafruit MagTag. Great little board, highly recommend it. We also have a sign up if you want to take that workshop remotely. But basically, we use Zephyr because it's an ecosystem, not just a real-time operating system, it's an ecosystem. So pulling in, so for a demo I did recently, there was a rangefinder sensor, and it's in tree, and you just get the code. You just get to basically pull in that entire driver, and the data just pops out of it. And so you think about that as an enabling thing as a dev shop. You need to just get some kind of sensor data without having to think about it too much, without having to re-implement drivers, that sort of thing. Arduino is, of course, another great example of this sort of thing. It's an ecosystem where there's independent people that are developing these drivers and pulling this stuff in. is an efficiency boost as well. So basically, again, we're trying to do more with less, and I think these ecosystems are going to be something, if you lean into them, if you even design for them. Again, I will ignore an entire sensor if there's no driver for it, because why would I? I mean, like, that's just extra work there. If I can get similar enough functionality, and if I can buy it, then I would go with one that has code. So it's like a design process that gets pushed back up the upstream into hardware. Finally, on the build tools and automation, if you build your test systems so that you are reducing your own errors, right? So if you start to take on CI/CD type stuff in firmware, this is something that's 20 years later, the firmware industry is getting all the stuff that the software people have been talking about a long time. It's great, but this is basically reducing the need for that test person later, because now your test system is checking all your stuff as you go along. There's also hardware stuff, like the blue clover thing on the right there. That's like a production level test, and that allows you to not only do the CI/CD, but then push it down to hardware-based testing as well, and is automated. So it's all about that automation and taking on more of the work. All right. Mechanical engineering, not a strong suit of mine. We're going to increasingly less strong suits of mine. But again, we're just taking on more of the process here in a proof of concept manner, right? I'm not designing a million shot injection molding kind of thing. That's not me. I'm never going to do that. However, I can do some of the design, and I can really make it so that an end client can put this thing out in the world and test and see if it's a good fit for their business. So, accessible 3D modeling, machines, and fabrication services. So, 3D modeling. FreeCAD, I love open source, but FreeCAD is still a little bit behind the times on stuff. I love it, I use it, but man, I miss Fusion some days. And Fusion is a good example of built-in CAM. So again, if you're designing in CAD and now you need to move to CAM and you want to do stuff in your shop, which will be the next thing here, the next slide, being able to do more of it and pull in more of that manufacturing stuff so that you can quick turn on your own basis there. I think another big one is vendor provide models. So now there's more and more 3D models you can just go and download and pull that in, so that maybe you don't even get to the manufacturing step or the physical prototyping step. You're just doing more 3D modeling and visualization using these and doing some of the rendering that's built in. So the rendering is now also built into many of these tools as well, so that you can make something that looks really real and you can test that and send that to your end client so that they understand what you're trying to build and what you're trying to do for their end product. Again, with this community, everybody's going to be like, oh, 3D printers, Chris. What a wonderful slide to tell the Hackaday community, guys. Have you heard about 3D printing? But I think really the prosumer level getting pushed down into the lab as well, so like resin printers. Milling machines, routing tables, all of these things are making it easier and easier to do kind of that quick turn, try stuff out. It's not going to be super high end again, but for a one engineer dev shop, it's the iteration piece, and in order to try out more things quickly. I think when you are trying to go a little higher end, so sending out, I don't have a laser cutter personally, but using Pinocchio is just like so fast and so easy, and I can basically buy my way out of time crunches. That's another important thing there, where if I want to do more, if I want to do it faster, I can usually pay for a little upgrade there as well. So a range of different services here. Again, probably not a super surprising thing to any of these other folks in the audience, but useful ones and ones that I like. Send, cut, sent. Sorry, I cut off the end of that word. Okay, on the device side now, this is because I didn't know where to stick this one. Hardware as code and prevalence of the Linux systems. I'm sorry to all the FPGA designers out there, calling it soft. I don't know, software, hardware, who to say what for FPGA designers. But being able to pull in that functionality and being able to do more with digital logic and more complex things on a device like an FPGA, again, you can do more stuff there, and now the open tool chain as well. It's just, you can do more stuff in the digital design realm. Linux accessibility, so being able to pull higher level functions onto a device for a prototype for sure. So you can put a dev board, plug it directly in like a BeagleBone or a Pi, but being able to then also pull that forward into a quasi-manufacturing proof of concept type thing as well. And then finally the images, right? So being able to build stuff, not just and utilize a Raspberry Pi, but to use Raspbian images, use community-based images there. And again, as a hardware designer, I don't have much capability. I'm not going to go probably build a Yocto, do a Yocto build for a Linux-based thing, but I can go and pull in Linux-based resources and quickly try stuff out. All right. Software engineering on front end, back end. So now this is kind of like into the web world as well. So back end side would be cloud services and scaling. Infrastructure, front end would be low code, no code, and app web frameworks. Again, we're focusing here on the doing more with less, right? So I am not going to go and become an AWS expert, but I can use things that might enable that sort of thing. Services and scaling. So you can set up a bunch of this infrastructure if you wanted to, if you had the capabilities to. Again, I don't really have it. But for example, the training that I did, I used a third-party program that then went and deployed AWS, like a bunch of machines. That's what everybody at the training was doing. They were using EC2s. That we had like 16 EC2s that were served up to all of the people taking that training. Me as an engineer, I don't know how to do that manually, but using software like that can go and deploy that, that's really useful. Golioth, which is my employer, basically making it easier to do cloud stuff for IoT devices. So connecting to, getting all this access to cloud stuff as a hardware engineer, that's really important to me. That's why I like working there. And there's other vertical hardware platforms as well that enable that same kind of thing. So without having to become a cloud expert, I can still access a lot of these things and do important things for an end client. In terms of the actual deployed infrastructure itself, I haven't done as much on the top one, the EC2 machine AMIs, but the DigitalOcean marketplace, like basically one click, deploy a discourse forum, and one click deploy a WordPress hosting type of thing. So basically being able to utilize this infrastructure without actually having to know how it is. You can get yourself in trouble, if you get into troubleshooting and you don't know what you're doing, but at least to get started, it's really fast to get started. And again, you can do more with less. You might want to stand up a quick blog just to showcase something for your end client as a one engineer development shop. You're not going to become a web administrator for them, but you can showcase these things and show more of it to them to prove out ideas. This is one that I do a lot. I use Grafana all the time, which is an open source visualization platform. Alex gave a talk about it earlier today. I highly recommend that sort of thing. Other ones like commercial offerings like Ubidots and DataCake are other ones I've used before. But basically this is to make a dashboard and to make your thing look better, right? So when you're putting a dial on screen, you want to showcase this stuff. Even things like, it looks like a mobile app almost, right? So you go to this web page, you see these dials. It looks kind of like an end product kind of thing. So as you're proving this stuff out, again, we're talking about as a one engineer dev shop, I'm trying to just kind of build a proof of concept in order to prove this out and prove it probably to an end client who then might want to go and hire someone later to make this super custom. Again, you might want to do this for an actual app, so things like Flutter and React Native, right? You can go and build these things as well. I'm not going to become a full JavaScript programmer, but I might be able to do like the getting started guides enough to have an app that looks good enough, that pulls in the client's brand and looks kind of close. Speaking of brand, this is the one that I was the least sure about. It was only because I had it on that initial list. I actually don't recommend you do this. I think as many of my coworkers have seen my bad art in the past, my bad brand design, it's not a good thing when I start doing this, but you might want to, you might need to do a little Inkscape, a little bit of Photoshop type of stuff, but I would outsource this first, honestly. And again, it's because tools are more accessible here. So if you are going to be using things like Adobe and Illustrator is just like monthly cost now, and that just kind of opens up a lot of options there. You might go open source as well. I use Inkscape all the time, and I love it for that sort of thing. I had mentioned earlier the rendering is built into the CAD program, so you don't need to learn like Maya and Blender and stuff like that, but Blender is open source. But often you can just open up KiCad, use the renderer, and it's kind of close enough to showcase what you want to show that would be in the industrial design side of things. You might be able to get away with it enough where your industrial design is much more than just the 3D model, of course. But in order to just kind of get over the hump and just to get that proof of concept out the door. But when you are ready to go external, the interchange formats really help to then send that to the real professional on that specified thing there. Of course, on the brand design, again, I don't really mess with that. But you can always utilize. You can go a little bit outsourced on this sort of thing, 99 Designs, Fiverr, Upwork. You can find some people. You could see, maybe manage that for your end client there. Speaking of managing, so we're going to talk a little bit about manufacturing Liaison, right? So this is like, you've gotten the proof of concept far enough, and you might want to take on a little bit more even. So you're going to be doing some PLM sort of thing. So PLM is things like OpenBOM and Duro and tracking parts, things like FineChips.com, a wonderful supply frame product. Partsbox.io is another one for managing small projects and when you want to build your own parts and stuff like that. And again, I'll call back to the no-touch and low-touch assembly. This kind of removes some of the stuff. You can do more with less by handing it off to someone else. In this case, you're just sending them the initial BOM and they're building this stuff for you. One more drink. I think I only have one drink left. Okay. So, project management, again, you might not want to take on more of this project, but it is going to be a part of your process as a dev shop, right? You're going to have to report back to your client there as well. And so there's a lot of workflow tools here. Probably seen them out in the world, Monday.com, Trello, Jira. But really it's about, and you're going to be using what your client's using as well. So it's important to just be flexible in this realm. If you want to take on more of that management, you often can. Personally, I found as a dev shop, I think it's important to push some of that stuff off. You're going to be managing maybe a subcontractor or two, but really, I think the main thing you're managing is your customers' expectations. So work within the tools that they want, suggest the tools that you like if they don't have anything they care about. It's going to depend on, kind of how much they've done hardware projects in the past. And ultimately, what you're trying to do is to understand how to get that thing out the door. The last one I said was supporting roles, and so these are things like accounting, purchasing, procurement, shipping, HR, marketing, sales. Again, if you're a one engineer dev shop, you're doing all this stuff anyways, often for your own business, but you might maybe want to help out with this for an end client. And so really just some tools here. Actually, what was my notes on that one? I had a note in here somewhere. Oh yeah. I do not recommend outsourcing your accounting. Generally, you shouldn't, don't try and be your own accountant. That's a dumb idea. But again, you're going to be maybe using tools like this so that you could tie into your accountant stuff and just make your life easier, become a more efficient machine as a dev shop, right? So understanding your own business is going to make it easier and allow you to focus on your client needs later. And so I think things like QuickBooks and Zoho. I use Zoho personally. It's okay. But it also is like a kind of all-in-one tool, and that's why I use it, because I invoice and I do all my tracking and sort of stuff in there. On the procurement side, I think like leaning on a lot of the vendors, like the DigiKey tools, Mauser tools, stuff like that, that's going to probably be enough, right? If you're getting to the point where you're like, oh, I'm doing all of the BOM stuff for a 1,000-piece run for my client, that might be time to think about moving outside of your own dev shop, especially if you want to be doing the design stuff. HR stuff, I really think about HR in terms of like tracking your own hours, tracking your subcontractor hours, that sort of thing. Marketing, again, this is probably more on your own business side of things, so things like social media and blogging. And then finally sales, again, this is probably you're not managing this stuff for a client, but things like Tindy. Tindy's great, DigiKey Marketplace is great, Shopify is great. So I have a link here. If you are a consultant, dev shop, you want to join the consultant forum. It's a semi-private forum. There's an application here. People that are interested in the space, I think there's a lot of kindred spirits there and a lot of people that are talking through these kind of problems on a daily basis. So check that out, consider applying. And here's all the places that you can find me, including the new home on chaos.social. That's all for me. Thanks so much.